Hi guys, and welcome to yet another devcast. We are going to talk about an update of the Dash animation system, and I'm going to delve into the NodeFlowData attributes and variables inside the system and how to use them. So let's jump into it. First, I want to mention that I will be releasing a new update, 0.2.2, still in beta, right after this video, and this is the changelog what was fixed, changed, added. There were some other changes as well, but they were minor, so I just put everything down that had any kind of significant impact. Actually, there are very few fixes, so which is maybe good, maybe not. I hope you guys will report more bugs so I can fix them. So I focused on the changes and additions. The main additions were additional nodes, changes to retargeting. Now you can even recursively retarget, use find to retarget, and I also added a lot of expression functions that you can use inside parameterization. We will talk about today. Additionally, I added a lot of error checking inside the runtime. So now if the graph stops or something is not behaving as it should and there is an error, it will let you know more precisely than before. So it will just go into an error mode, you will get a warning and stuff like that. And finally, I switched from encalc, from the old encalc implementation to a new one, which is faster, and additionally removed some external dependency from NTLR. And finally, also I added a new preview mode where you can change the node you are trying to preview. You can instantly preview nodes, so you no longer need to preview only the entry node and preview everything you are doing on the entry node. You can preview pretty much anything. You just need to be aware of the retargeting. So let's jump right into the concepts of what is a node, what is a node flow data, what is the attributes and variables. Some of it I already mentioned in previous video. So let's say we have a node which is the stateless entity in our graph. It's driven externally. It doesn't have a status because you can run the same node 100 times even in parallel, and it should always execute the same way unless the external parameters changed. So node is driven by the node model. Each of the nodes has its model, which can have properties. These properties can be values that you can specify directly inside the editor, or they can be parameterized. So, and if you use parameterization, they are evaluated as expressions. So let's say there can be multiple expressions because you can have multiple parameters. So you can have expression. Expression to drive your parameters. And inside these expressions, you can be as simple as binding a parameter to a variable of the graph or binding it into an attribute inside the flow data, or it can be a function or a reserved parameter. So let's say let's start. It can be a function. You can also combine these, obviously. It can be a function. For example, there can be function like getTime or getChild at. You can put a getChild at target 1 or something like that, and it will get the child of target at the first index. So it can be driven by function, but you already have an attribute there because target is an attribute. It can be a reserved property. There are some reserved properties inside, for example, time. If you just put time into an expression, it will return a float of a current time. It can be, there are some other reserved, already predefined parameters that you can use that are global, and there will be added probably more as well. You can use variable or variables. These are the variables we already saw. They are on the graph. So they are bound to the instance of the graph. And they can be, again, either constant or they can be bound to a external property, to some of the components inside the controller. So they can be either values directly or they can be bound. They can be bound into a property of a component or the additional component on the controller game object, for example. And finally, you can have attributes. Attribute. These attributes, some of you asked what's the difference between an attribute and between a variable. These attributes are going through the graph. So they are inside a NodeFlowData. NodeFlowData is basically an attribute container on our attribute collection. So each time, for example, we have this graph, there is this node, it goes to this node, this goes to this node, and this goes to this node, and we execute this one. We are sending an instance of a NodeFlow data. Which is, as I said, an attribute collection. It can have any number of attributes. There is no limit. There are already two reserved attributes, the reserved name, and they should be inside the NodeFlowData. And in most cases, the controller automatically injects these two attributes into the NodeFlowData if you use a send event or you have an entering graph. And these two are target, we were already talking about, which is used by almost everything by default. And the second one is controller, which is a transform of the controller where the graph is. Both of these are transforms, target and controller. If you don't specify the target when you are doing something like sending an event, both of these will basically reference the same transform, because the default target, as I mentioned in previous video, is the transform of the controller. But sometimes you want to have knowledge about the transform of the controller deep inside the graph. If you retargeted it a couple of times and you still want to reference a controller, that's why there are these two. It may change in the future, but this is for now the best implementation that I came up with. So if you send this NodeFlowData into this node, it can modify it inside the node in some way. But before modifying the data, it always clones the data. Also, if it executes the input, it also clones the data. So this data is cloned inside by default. It's cloned inside the graph multiple times. This cloning inside the node, like the implicit one, is happening mainly if we have like multiple outputs. So each output gets its own data clone, because there can be delay between the outputs, and we always need to know that we are not changing some references for other data basically. And this implicit cloning is also happening. So if, for example, if this node, this one, is a retarget node, and it retargets the target attribute, it's out inside the data, it will not affect target inside this node because it has its own clone of the NodeFlowData collection. And that's why if you are working on a NodeFlowData inside a node, you don't really need to be aware of the asynchronous changing of the flow data inside other nodes. It's always down the pipeline cloned as it goes, and if it's even forks or there are loops, it always clones the data. So you are basically, if you are changing the data, you are affecting the nodes to the right, no, never affecting the nodes that are somewhere else in the graph or that are executed before you. Even though they can be still executing, it will execute on their own data. And as I said, these attributes can be sent from outside through the NodeFlowData. Then they can be used to inside the expressions to change the model, the model of the node. And these attributes can also be changed inside the graph. We can have special node called set attribute. So you can do something and set an attribute for part of your graph, then you can remove the attribute if you want to. So that's a bit of deep dive into the functions, expressions, variables, and attributes. And now I will show you how to put all of them together and work it and create a somewhere more robust graphs. So let's start. Let me switch to Unity. So I created this simple screen too. This is the first screen from our previous tutorial, but I created this new one. We have these three items on top, gold, gems, and some kind of leaves, so lucky leaves maybe, with some numbers. So, and we are going to create a graph that will basically spawn one of these items and then animate them to the top and add the amount of items. So let's start. As you can see, there are like these three items, very, very simple. So let's start, create a dash controller, create a graph, and we can open the editor. Since we are going to spawn them on mouse click, we don't really want to create an entry node we used in the previous tutorial, but we want to create an even node. We could create an on mouse click, but this node at the moment only checks mouse click on button. I will maybe add a special node that can check a mouse click on screen as well, but that one only works on buttons at the moment. So if you want to check a mouse click on button, you can use that one. But we will check the click outside of the graph and send it inside the node, just to show you how to send events inside graph. So we will create a custom event. This custom event will be called click. And we want to spawn an image right away. We can spawn image, so let's say we want the gold, the one without the shadow. Okay, just connect it. And we want to animate it. So let's say we want an animation and animate it on 3 seconds out back, my favorite, and relative, let's say 100 for now. Okay. This we need to check one more thing. We want to retarget to spawn because otherwise this would animate the target, the screen, which was the default target. I will probably make this property true by default because we want to retarget to spawn. There is an advanced option we can show you is that you can create a new attribute and then retarget to it here. But let's say we want to by default retarget to spawn. So now the target is the spawned image down the graph. So let's just show you a new feature of this update, which is instant preview. So we can instantly preview this animation. We can even instantly preview here. Doesn't really matter. Even here, but it wouldn't change, show you anything because without these two running, it would just run this one. It would try to animate the screen. So we can even set these to default preview mode, so we can then run it through the preview controls as well. So that's nice. Let's add more of these because we want to obviously add more coins. So let's use a for loop node. And let's add 10 of these. So it will execute 10 times. So there are 10 of them, obviously, we can even check. But they are all at the same position. So what we want to do, let's spawn them at the same position, doesn't matter, but animate them differently. So what we can use is parametrization of the to position. This settings icon, if you see it on any parameter or any property, it can be parameterized and then driven by an expression rather than a value. So we can use one of the functions that are inside the framework, which is called random. This function is generic, so it will automatically look up for the type of the property and try to find an implementation of itself for that type. So if it checks that to position is a vector 2, it will try if there is an implementation of the vector 2 random, and it will execute it and then return a vector 2 value. So it will not work, for example, if we, because you can use random, because this function has always two parameters, which is the minimum and maximum value. Let me show you. So we can even check this. And now you see that it will animate these to a random, basically circle. But let's say we wanted to randomize this. You cannot do random because this random function would also look for the type of the property, and it would try to create an instance of vector 2. It cannot create an instance of vector 2 because it wants a float. So there are explicit functions for specific type creation like random f. But for now we don't really need to randomize the minimum value. It doesn't really make sense. So now we have all these nice coins. So what we want to do is animate them, and we want to animate them to the top, obviously. So I will add additional animation after this one. Let's say we want again 0, 3, and it will be in back in this case. And we don't really want to from and to position. So let's say we want it to minus 400. I don't think it's like here, just a constant value for now. And we don't need retargeting because it's already targeted there. So let's run it. And as you can see, it works. Okay, it works, but if let's say we want to change it depending on what type of item it is. So let's delve deeper into the variables and attributes. We can check the variables here we wanted to. So for example, we can, there are some more variables from previous video because I added them, and there will be more added as future versions comes. But for example, we want the position to have it here, the target position. So then this can be parameterized to g new vector 20, because as I said, if you want to reference a variable instead of an attribute, you always use g underscore. So let's run it. As you can see, it works. So if we had this graph for simple executions, we can then bind this externally to, for example, some kind of property and switch it. Okay, this graph now animates everything to gem or everything to the gold. But let's say you changed it, and then in the same second or at the same time you wanted to spawn gems, it would evaluate this function at this node which is in a 0.3 seconds. So if this changed externally before this evaluation, it would be at the new value. So it doesn't really work like that. This is basically, once it's changed, it will apply at that time to everything that requests it. So these are basically not good if you want to send the information down the data flow, and this information can change in any time. These are way better suited to be global variables for that graph. So we want this position to be driven externally. So it needs to be sent to the graph once the event click is fired. So what other things we actually want to send there? Let's say we wanted this icon, because if we want to spawn a gem as well, we don't really want an icon to be spawned, the icon of the gold, but we want the gem icon. And also we can probably drive the amount of, for example, we can drive the amount of coins. Let's say we had something like that. This we can also parameterize the amount of coins to g count. Now it will spawn 100 coins. Let's say we want to even parameterize this random. We can do that, easy as that. So the amount of dispersion can be driven. But let's say we want just let's leave this count here. Let's delete this one, and we want this target position. So now I'm going to show you how to call this event. We have a controller. I already prepared it. I will add it here. Test controller. Every mono behavior that I use that just controls a single entity, I always call it controller. If it manages multiple entities, it's a manager. So that's my naming. It's not really needed. It's just, I said, it's a easy mono behavior. It has two properties. One of them is sprites, where I already defined. Oh, that I didn't define. I will define them. So we want 3 different sprites here. Okay, it's a gold one. We want the 128 one. This is a gem. Again, I want this one, and the final one, I don't know the name for the leaves. It's this one. Okay, so I have these 3 sprites. I could also define them here as 3 different variables, but there are multiple approaches that you can choose. Here I'm just showing you some of them. So we want to send an event into the graph. There are multiple ways to send an event into the graph. You can get a component directly and send an event there, which will just send the event to the component, to this single component. We can also use a Singleton core, which knows about all the controllers that are active inside the scene, and we can send event globally. So this I'm using this Singleton to send click event to all the graphs that are there. So if there are any other implementations of the click method, it will execute them. So, and as I said, we need to send the data into the graph, which will hold the attributes we need. I'm not sending target, nor I'm sending the controller, because the dash controller will automatically check if there is a target and a controller attribute. And if there is none of them, it will automatically inject them. So I need to focus only on the attributes that I need additionally. So as I said, I am going to send the click position, the mouse position externally, because there is no node that will just check the click at the moment on the screen. So I'm just getting the mouse position from the input directly, but since mouse position on input is actually vector 3, I need a vector 2 because I'm going to work with vector 2. Then I'm just taking the rect transform of this game object, and then I'm changing the mouse position, because the mouse position is screen position. You already know that if you worked with any kind of mouse positioning inside the rect transforms. It is not actually the position inside rect, because the rect can have a different pivots. As I can show you that this was minus or it's not here, it's here, minus 400, 900. So this is a position, because and on the screen it's actually positioned around 100, 100, but we need this this position recalculated to the canvas. So I'm just using a rect transform utility and calculating the point from the screen to local space, and then I'm sending this point to the graph. So I'm going to use this spawn position here where I'm spawning it. So it will no longer be 0, 0, it will be spawn position. Next, I'm doing the same thing for the position of the target child I want to use. It's driven by the type integer, so type will be the index of the child, either 0, 1, or 2. So I'll get the transform of the child, and again transform from one space to another space, from the child space to the parent space, and I will set it to position, which will drive the to position will be used here. So it will not be target position, it will be to position. I am also sending the type. We are not going to use it yet. And I am sending the sprite, which will be attribute of type sprite that will have the correct sprite based on the type I'm using. So here I can just parameterize this and use sprite. If I run it like this, it will not work because sprite is not found. There is no spawn position, because this is obviously executed only or during runtime. It's not executed at editor time. So there will be probably in future updates some kind of like dummy attributes that could be used for injecting these attributes, but at the moment we don't really care. We will use play mode and run it to see it. Now as you can see, it just spawns where I click and then automatically animates into the position. If I go to the type 1, it will spawn gems. And if I go to 2, it will spawn the leaves. We can also, if we want to add, for example, the count as well. So let's say we want the temp, then set attribute int count. I will use range from 0 to, let's say, 100. And then inside the graph, I can go to the for loop and go from g, which was the graph variable, to count, which will look at inside the attribute. Again, and if I run it, it will spawn 10 of them. If we go higher, it will spawn a lot more or less. So now, as I said, since it's driven from the data that goes in from outside the graph, it's always correct. Whether if we change this one, you could like go into an asynchronous situations where it shouldn't be changed yet, but it would be. Okay, so now we want to animate this once it's hit, so it just like jumps. So we can use, for example, okay, animate scale. And let's say once it's hit, we will animate the scale. The problem here is that we want to animate this, but this is targeted to the spawned image. So what we can do here is retarget, but since this scale will only scale it up, and then there would be another animate scale to scale it down, I would go and retarget it using the retarget node. So everything down the stream will use this new target. Okay, now we are going to retarget, and what we can do is target. We can do, for example, target item 1, because in the whole hierarchy it would just like this. Okay, because it would be the only item 1 there. We are not going to do that, but I will just show you that it should actually work. And as you can see, it works. We are not targeting it down. So animation, animate scale. Let's say this should be 1. This should be 1. And now we are going to, since we are not using relative, we are going to 2 and then to 1. So now it should just scale. We can be okay, but there are multiple things we can just make it more fancy. Firstly, we obviously are not destroying these images, as you can see. So let's add that. If it hits, we can just use destroy. It will destroy this target because it's no longer we no longer care about it. Let's check. So okay, as you can see, the images are getting destroyed. Additionally, we can do a bit of delay, so per iteration, so the items will jump more lively, something like this. We can make the delay more longer or smaller, so it looks cool. And as you can see, since we are targeting the item 1, doesn't really work, because we will always target the gold. We will solve this, but for now I would really go with a smaller delay, because this would take ages. We can actually use the delay like the count. Okay, so something like this. Oh, we need to parameterize it, obviously. So something like 1, so it should be dependent on the count. No problem. But I'm going to solve this first. We don't really want to use the string. We could just go with the type. We already have the index inside, so we could just do some kind of string magic to create the name. But I'm going to use a reference and use a parameterized reference. This is a new feature in the new update, because these references inside the framework were not you were not able to parameterize them, because they were already a generic wrapper types. Generic wrapper types couldn't be parameterized. Any type that is actually a generic type couldn't be parameterized. This is solved by a different approach to parameterization into generic wrappers. So now there is a special attribute that inside the framework enable you to parameterize generic wrappers. So for example, this type by default value is an exposed property. Exposed property of a type transform. That's why it's a generic. And if you parameterize such a property, you don't really want to parameterize the exposed property of type transform. You just want to parameterize the transform itself, because the evaluation of the expression should be a transform, not an exposed property. You don't really need that. That's just to store the scene references. So we are going to use a target reference, and we can use a method getChildAdd, and this one should actually work. Let's try it out. As you can see, now we are going to the target we want. That's the beauty of parameterization. So this method has two parameters. First is a transform, which we are looking at currently. It can be the target, it can be any transform. And we want a child at index of that transform. So we basically asked the expression for a type, which is the index we are specifying, of the controller transform, which is the screen 2. So we 0, 1, 2, we are asking for these 3 children. So we could actually change, we could actually, this position, we could be you calculated using a parameterization, because the 2 position would be just the position of this transform. But that's the beauty of how we want to approach it. We could also send this as an attribute if we wanted to. So we could just have a like 2 transform or something like that, no problem. Now here we want to, if we run it, it just jumps, all of it jumps. I just want the coin to jump, not really the number. So we are going to retarget. We are going to retarget to the child using a string, and I want just the image. We already have this target. That's why we use this retarget node to change the target down the stream. And again here I want the image. So now only the coin should animate. Let's see. That's what we want. And now what we actually want is add the number to the text. So we have a logic, I think is incrementText, is a new node. And we want to retarget because we want to change the text on the label. Because if we just did a retarget, it would tell us that there is no text or that transform we want to increment. If we want to use dot formatting, in all our games we use dot formatting between thousands and millions and stuff like that, so I just use it. You cannot change this in between because it expects the text already to be in dot formatting. It will reparse and then set it to dot formatting as well, so it should already be in dot formatting. And we want to increment it by 1. It will be incremented by 1 every time it's hit by a coin or any type. So let's look. Okay, now that's what we wanted. And now we can change these types, the amount. And as you can see, since it's down the stream, it's still the same graph. In the middle of execution, I can change these. Oh, now I switch to an index that doesn't exist. So that's obviously an error, but that's not a problem with our graph. I will add additional error checking as well, but this is not in the scope of this, so I just want to once again spawn some more coins, and it's all executed on this single instance of the graph since it's externally driven by an attributes. So I hope you enjoyed this tutorial. If there are any questions, feel free to ask. It will be updated on the GitHub. As I said, the development branch will be merged to the master one and new development branch will be created. If you have any like feature requests or maybe even you want to talk about the usability of it, the user friendliness, because I'm aware that some of it is like not really that easy. If you have ideas how to simplify this, I would be very keen on hearing them because I'm thinking about it from a non-technical standpoint as well, and I want to make it simple and more intuitive. So if you have some ideas how to do that, it's one of the priorities of this project. Just write to me and we can chat. So that's all for now, and thanks for watching.